Welcome to Medusa Pro, 3D rock model generator for Windows. In this short tutorial we're going to show you how easy it is to customize models in Medusa Pro and some of the more advanced features of the software. So it's really easy to generate random models of the current template. We just press the space button and Medusa will now generate a completely new model based on the geological properties of the template that looks very different from other models. But we can also change this template. So if I click on the middle mouse button to bring up the context menu and go to Show Properties, the Rock Properties menu is displayed of the template, and this describes all the geological properties that control the appearance of the current rock template. And there's several different categories on here that control different aspects of the rock. Probably the most important are the block categories, and this really is fundamental in geology. So this controls the blocks that define the shape of our outcrop. So the very prominent layers that come across the outcrop are known as bedding to a geologist, and certainly in sedimentary rocks these result from the accumulation of layers of sand or mud or shells. And we can change various properties of these different layers. So for example, we could increase the minimum and maximum thickness that are used to randomly generate the different beds. We could change the protrusion, which controls how far the beds stick out at their ends, and the protrusion variance, which controls how random that protrusion is from the end of the bedding. You'll also see we've got two different types of bed 1 and bed 2, and this allows us to have two different kinds of layers. So you'll see here that bed 2 is much thinner. So what I can do is I can tell my model to have 70% of bed 2. So this is going to be many more thin layers, and if I press well bedded and go to create, we'll get a new model, and this time there'll be many more thinner layers than there are thicker layers. So here we are. We can see that there's many more thinner layers here than the thick layers. This function well bedded is a term that geologists use to describe how well defined the layering is, and you can see that the layering on this model is considerably better defined than it was before. We can also change the angles between the different planes used to make blocks to create this rock model. If we go to enter the wireframe view, we can quite clearly see the bedding planes, so these very prominent planes, but also we've got planes that cut the model in two different directions. And these represent joints in geology. Joints are just simply fractures that occur because of the rock's been stressed, and you can see that they're effectively controlling the shape of the model. So for example, we could make the joint 1 to 2 angle something very small, so let's make this 60 degrees, and this will generate quite a few extra faces, but we'll change the shape of the model. And so now the model will have much sharper edges. There we go, so we can see that the angle between the joint 1 and joint 2 has been decreased. So this produces a much sharper looking model. We can also change the bed to joint angle. So this is the angle between these very prominent bedding planes and the joints. Let's again change that to something quite small and click create. And so this time the blocks will appear to be slanted, and this will generate a much more angular looking rock model. And the difference really depends on what the rock's made out of. So for example, soft sedimentary rocks tend to have joints and bedding that are almost 90 degrees to each other, whereas hard metamorphic rocks, for example in mountains, tend to have these very angular, sharp outcrop shapes, at least when they're fresh and they've not been exposed to weathering, to erosion by water and ice. So let's set these properties back to 90. so that we can test some of the other features of Medusa Pro. So the next group of properties in the template are folds, and rocks are often folded by the quite tremendous forces caused by earth movements, for example by the collision of continents. And Medusa allows us to apply two sets of folds, because rocks can be folded more than once, but just for now we'll just add a single set of folds. So I'm just going to set the amplitude of one of these folds, and the amplitude is the height of the fold. Set the amplitude of one of them to 0. We'll click add folds and we'll see what this does. So press create, and this should now add a fold to the bedding. So you can now see that the bedding has been folded. So we've got this quite nice fold being applied to the bedding. And how sharp the fold is really will depend on the mesh and on the bedding and joint size. So if I randomize this again, it will generate a completely random model, but again with the same folds applied to it. We can change all the properties of this fold. So for example, we could make this fold longer, so we can increase the wavelength. Let's increase the wavelength to 2 and create that model. And now this fold should have a much larger wavelength, so it should be a much more gentle fold, the kind of fold, for example, we might see in lowland regions where folding is not usually quite as intense as in mountain ranges. Let's go back to a wavelength of 1. The next property is the phase of the fold. Really, this determines where the axis of symmetry of the fold is. So you'll notice by looking at this fold that there's a plane through here, which is a plane of symmetry through the fold. And to a geologist, this is called an axial plane. And if we increase the phase from 90 to say 270, and that phase is in angle, and press create, it will change the location of that fold axial plane. So here we are. The fold axial plane has now moved to over here, and it's changed the appearance of that fold plane. And we can also set that to 0. Press create, and again that fold axial plane will move along the rock model and change the overall shape of the model, which is controlled by where the blocks encounter the outside of the shape and the geometry of that fold. So let's set that back to 90. The last properties here in folding are the dip and dip direction of that fold axial plane, of that plane of symmetry. So you can see the plane is almost vertical, it's 90 degrees, and the direction is towards 90. Let's now set that direction towards something different. Let's set it to 45 and press create, and that will change the orientation of this plane of symmetry of the fold. And so now that fold will actually run across the model in a different direction. So you can see with this model that's generated around a cube shape, that fold is now running from one corner of the cube to the other corner of the cube. So we can use folding to generate some really different fold shapes. We can also add a second fold, and folding in multiple directions is quite common, especially in mountain ranges. And let's set the amplitude of the second fold back to a positive value and press create. And now this model will have two separate folds which fold each other, and that we might expect in for example, metamorphic rocks that we find in mountain ranges. And you can see that we've got one fold that's running in this direction, and then a second fold, a bowl-shaped fold that is running across the rock model in the opposite direction. So folding allows us to generate some really quite impressive models. Let's get rid of that second fold for a second and investigate random wavelength. A random wavelength will choose a random length of our fold across the rock model, and this time I'm going to increase the Y size of the model to 4, just to make it easier for us to see multiple folds. And I'll press create, and the fold will be, several folds should now appear on the model with random wavelengths to generate some really realistic looking folds, which would be great, for example, for a cliff face or for a very large expanse of rocks. Now I've increased the size of the model, so this is going to take longer to generate because it's producing many more phases, and there we go. So there's a nice cliff face with multiple sets of folds superimposed on that cliff. The final function here is called chevrons. There are actually two different kinds of folding. There are rounded folds like these that are nice and smooth, and then there's also quite angular folds which are V shapes, and Medusa Pro can also generate these chevrons. So I can press create, and it's now gonna generate random folds that are V-shaped onto our rock model. And again, this model is quite large, so it's going to generate significant numbers of faces. So it's currently about 4,000 faces. And here we go. So here are our V-shaped folds that have been superimposed on this model. And you can see it's a very different appearance. So let's turn off our folds again. The next group of properties control the relative size of the model compared to the underlying shape, which is pretty obvious really what that does, but also the dip and dip direction of the beds. And this is actually quite important in determining the size of the model. So I'm just going to set it so we've got a dip of 21 degrees, and this dip of the bedding is along the y-axis of the model. And let's press create, and you're going to see now that the bedding will be dipping at exactly 21 degrees relative to that y-axis. The dip direction controls the direction in which those beds are sloping. So if I put, say, 45 degrees in dip direction and press create, now the beds will be dipping between the x and the y-axis. And that actually changes quite considerably the appearance of the model, because it's the interaction between those beds and the surrounding shape which controls the overall geometry of the model. So you can see now we've got all these step features and a little protrusion of the bedding on one corner of this shape, which is obviously based on a cube. We can also choose to add a variance to the angles. So for example, if I put 30 degrees there, dip directions towards 0, and a dip variance, say, of 60 degrees, and press create, now every time I generate the model, it will be the dip is generated randomly, so it will always be different. So this increases the randomness of the model, and if I select a new one, each time we create this model, it's going to create a very different looking rock outcrop on the basis of that dip. So the dip will vary between -10 and 30, and the dip direction between 0 and 60. The final group of properties down here on this side are the materials. So we can change the material. Let's change the material to, say, a red sandstone, and we can choose whether the material is bedding orientated. So that's whether the material is parallel to these beds, and we probably want it to be parallel to the beds for something like a sandstone. Also whether the texture is wrapped, so whether the texture reflects as it goes around as it's mapped around the model, and if you have wrapped texture on, then you needn't use a fully seamed texture. And we can also control the size of that texture. So for example, we could set that texture to 1, and let's press create, and now this will generate a model with a new texture at a different texture mapping size. So we can see now we've got this red sandstone texture applied to the model. We can, if we want, then change that texture again from the context menu just for this particular model. But we can also specify this in the rock template. So let's set that back to 0.5 and go back to my nice yellow limestone. The next group of properties control the randomness of the model. So the first group is the number of islands, and islands are random islands that are built up on the surface and effectively generate lumps on the surface of the model. So I've increased the number of islands, so now the model will be considerably more lumpy. There will be more raised portions on the surface, especially on any flat surfaces that we generate. And you'll find that the number of islands will generate a considerable amount of randomness. We can also choose to add random noise, and in contrast to the number of islands, which generates larger areas, larger raised areas, noise will just move vertices up, down, left and right, depending on the values within each one of these edit boxes. We can also specify the amount of variation, percent variation we want in the size of the model between each random creation, again increasing the randomness when we create new random models. We can choose a shape category. Now the shapes control the overall geometry of the rock model. At the moment this is selected to primitives. I could ask it to make random versions of arches, for example, or caves or cliffs, but we'll keep this on primitives. And these shapes we can see in the shape library. So these are all the shapes that are available and come with Medusa Pro, but we can actually import new shape meshes from collider models produced in a 3D editing software. We can also select to use any shape in the library, increasing the amount of randomness. And then finally, under randomness, we've got the maximum shear angles that we use to deform that underlying shape that produces the rock model. And we can actually see in this model, if we go to View and Show Shape, that this model is based on a sphere on one of the primitives. The final group of properties in the rock template control the detail aspects of the model, such as smoothing, bevel, and cracks. Smoothing will obviously smooth the model. We can apply this to the entire mesh, or just to the outer corners, or just to the inner corners. We can also ask it to do a vertical smooth, so it smooths the top of the model more than the bottom of the model. So let's add a vertical smooth and press Create. And so this will now generate a much more smooth top to this model than the bottom, which is actually very similar to water erosion that occurs in nature. Bevel does a very similar job to smoothing, except bevel will add extra faces. So we'll round those corners according to the bevel angle. So any interfacial angle that's more than 60 degrees will have a bevel added to it. And according to the bevel distance, and bevel distance is in world units and controls how large the bevel faces are. So if we add bevel and press Create, then our new model will be rounded not by smoothing, but by adding new faces. So obviously this will increase the poly count of our model. So you can see the number of faces is increased. It's taking longer to build the model. It's just calculating the UVs, and there we are. So there's a beveled model, and actually this rounding is produced by new faces. We can go into wireframe and see that additional resolution. So it's a very good way of producing much higher resolution models, for example for items that are going to be seen really close up. Let's go back and see the diffuse model. And the final property over here is adding cracks. Cracks will generate new faces to make furrows on the surface of the model, and we can control the depth and the width of those cracks, the number of cracks to add, and the length of the cracks in terms of the number of edges. We can also specify whether we want those cracks to be parallel to the bedding, parallel to joint 1 or joint 2, or completely random. And let's try parallel to bedding, and I'm going to take off well bedded to do this, to make it really obvious where the cracks are, and then we'll generate this new model. So we can see we've got these bedding parallel cracks, these little furrows being added to the model, generating a furrowed appearance, which is actually very similar to wind erosion or chemical erosion, especially at coastlines. We can also change the order in which smoothing, bevel and cracks are generated, because of course if we smooth the model after we've added cracks, then that will reduce the intensity of those cracks. So for example, I could switch it so it does crack first, then bevel, then smooth, or so that it bevels, smooths and then cracks. The last two properties here are to deformation properties, to pinch or to twist the model. Let's have a go at twist. Twist is on the template is around the z-axis, and if I press create, it will now generate a new model, and it will twist that model around the z-axis, and on each time we create that model, it will produce a somewhat different appearance. So there's an enormous number of properties that you can change in the rock template that affect the exact appearance of the rock model. And you can change a previous template, an existing template, and save those changes, or you can generate a completely new template, which is an entirely new type of rock. And to do this, we simply select the template in the rock library and then select new, and this will use that pre-existing template in order to populate all these fields. We can add a new template name and change the properties of our rock template, and finally save it to the rock library, and then that template will then appear within the rock library and can be used to generate new random rocks. So we hope you agree that Medusa Pro can be used to generate a really enormous number of completely random rock models. So Medusa is available for download now. There is a free version of Medusa Lite, which allows you to make only random models from existing templates, from 2 existing templates. And we hope you enjoy using Medusa Pro and find it very useful to create models for your games and 3D rendering scenes.